Hello class. In this lesson we're looking at section 12.2, scatter plots. I think you've seen a scatter plot before. In scatter plots we're looking at the relationship between two variables. Often the x variable is called the independent variable. Those will have some quantity measurement, and it'll be compared to the y variable, which might be called the dependent variable or the response variable. What we're doing here is we're looking at the relationship or the correlation between the two variables. The correlation, that's a word you want to become familiar with, is the relationship between the two variables. All right. The advantage of this correlation, using these scatter plots, we can use this to predict the value of one of the variables given the other. So this is used for predictions. We're not quite there yet, ready to see this application, but that's something to keep in mind. Now the correlation value, we use R to symbolize this. The largest it can ever be is 1. That would be a straight line sloping in the positive direction. And the smallest that R can ever be is -1. That would be a straight line sloping in the negative direction. So we're going to look at 3 quick interpretations or examples of R. We'll look at R where it's equal to -1. Then we'll look at R where it's equal to a positive 0.8. And we'll look at an R that might have a 0.1 correlation, or maybe even a negative 0.1 correlation. So an R value that is -1 would be a straight line sloping in the negative direction with a negative slope. A correlation that has positive 0.8 would be a correlation that is somewhat sloping in the form of a straight line, but not completely. And R equal to 0.1 or negative 0.1, this is where we would say there is no correlation. 0 would be no correlation, but this would be close to it. And that would be the dots are neither seeming to go in a negative direction, nor they seem to be moving in a positive direction. They just seem all over the place. Well, let's end with a couple of thoughts here. Remember, correlation, we talked about this earlier in the semester. Correlation never implies causality. So just because we see a relationship, that doesn't mean that the one variable, that the independent variable, caused the response variable to happen. The other thing is relationships may exist even if they're not linear. Relationships may exist even if they are not linear. What do you mean, Mr. Everett? Well, we could have a scatter plot that has a relationship, and so we would say, there's a relationship here. It's just not a linear relationship. This would be something we've seen in algebra. This would be a quadratic relationship. Maybe the independent variable is temperature, and maybe the response variable is money. And costs are more expensive when the temperature is low because we have the heater on in the home. Or the response variable might also be high expenses when the temperature is high outside because we have the air conditioner on. All right. As we continue through chapter 12, we'll be looking at scatter plots and talking about things such as correlation and regression. I'll look for your questions on the discussion board. Talk to you soon.